want to generate the formula for a geometric progression, how do we go about it? I have already looked at series and sequences into details, including the introductory part. So kindly visit my channel, subscribe, and then get access to all the videos. All right, so the first thing that we want to do here is to write our first term down. And based on this set, our first term is equal to 3, and our common ratio, which is the second term divided by the first term, or the third term divided by the second term, or the fourth term divided by the third term. So what I simply mean is 6 divided by 3 must be equal to 12 divided by 6, which must also be equal to 24 divided by 12. The result will remain as 2, because 6 divided by 3 is 2, 12 divided by 6 is also 2, and then 24 divided by 12 is also 2. So that becomes our common ratio. All right, so we will be using the first term and the common ratio in order for us to be able to generate the formula for a geometric progression. So let's do that. So u1 is our first term, and it is always going to be represented by our first term, which is a. So u1 is our first term, and that is a. Then u2 is our second term, and that is going to be a multiplied by our common ratio, okay, and that is going to be raised to the power 1, but there is no need to write that. All right, so let's move on. Then u3 would be a multiplied by r raised to the power 2. Then u4 will be equal to a r raised to the power 3. Now, we can prove all this based on this set that we have. Our a is the first term, which is true, so that is 3. Our ar is going to be 3 multiplied by r, and our r is 2, and that answer is going to be 6. So our second term is 6, which is also true. Let's prove the third term. This is going to be 3 times our r is 2 raised to the power 2, and this is going to be 3 times 4. 3 times 4 is 12, which is also the third term, which is correct. Then the fourth term is going to be 3 by 2 raised to the power 3, and this is going to be 3 by 8, and 3 by 8 is 24, and that is also the fourth term. So we can actually use the set to be able to prove these formulas. If you observe these formulas carefully, you realize that anytime you have 4 or the fourth term, then our r, the power of r, will reduce by 1. This is the third term. It has reduced by 1, which became 2. Then this has also reduced by 1, in that order. So our general formula for geometric progression, we can boldly say that if we want to find, let's say, the 20th term or the 40th term, depending on what we want to find, we can use n to represent that. So this becomes n un equals, so we now know that n will be reduced when it comes to the formula. So this will become a r raised to the power n minus 1. So we have reduced n by 1 because n is here, and that becomes our final answer. So this is the formula that we will be using anytime at all we want to solve questions that involves geometric progression. I hope this helps.